You can see it later. So we are starting today covalent bonding. Okay. So just like any other bond, covalent bond is also an electrostatic force of attraction. Okay. So this is also an electrostatic force of attraction. Electrostatic force of attraction. And we know what is electrostatic force of attraction. Something positive attracts another thing which is negative. In case of ionic bonding, we have seen that cation and anion attract each other due to the complete gain and loss of electron. But here, there are no cations and anions. Why? Because it takes place between non-metals. Okay, it can be same type of the non-metals or it can be different type of the non-metals. All right. So when non-metals and non-metals react with each other, all right. For example, this one non-metal is going to react with sorry, another non-metal. When one non-metal is going to react with another non-metal. Now the question is, who is going to lose the electron and who is going to gain the electron? So none of them are going to gain or lose the electron. Rather, in order to complete the last shell, what do? You know, they share the electrons. They share the electrons. Where? In the last shell. So sharing of electron is taking place in the covalent bonding. So let me write over here nicely. My handwriting is not looking good. So let me type it over here for you. So what is a covalent bond? Let's write down the detail. Okay. So covalent bonding takes place between the non-metals. Okay. Covalent bonding takes place between the non-metals. So the non-metals share their electrons where? In the last shell. Share the electrons where? In the last shell, to have a full outer electronic shell. Okay, so in the last shell they share the electron with each other. So what is the covalent bond then? What type of electrostatic force of attraction it is? It is, or better to say, covalent bond is an electrostatic force of attraction between the shared pairs of electrons. I will explain you how. Shared pairs of electrons and the nuclei of each atom. Shared pairs of electrons and the nuclei. Nuclei is the plural of nucleus. Nuclei is the plural of nucleus. So we will see how. We will see now how. I am finished. Finish करो fast. Zabir, go and see, I think, your parents they might. Okay. Tell me when you finish writing, okay?
Yeah. Done.
Okay. Okay, now we will see the examples. How the sharing of electron is taking place. For example, what happens when two hydrogen atoms react together and they form hydrogen gas molecule? How? This is one hydrogen. Atomic number of hydrogen is 1. It means it has 1 electron. All right. This is another hydrogen. Atomic number is 1, 1 electron. First shell, according to the rule, must contain 2 electrons. But see, both of them have 1 electron. This hydrogen needs 1 more electron. This hydrogen needs 1 more electron. So what do? They come closer like this and they share. Becomes a little bit bigger. Okay, so they share the electrons like this. So this hydrogen, 1 electron, is shared by this hydrogen's 1 electron. So you can see this hydrogen is now getting 2 electrons in the first shell. This hydrogen is getting 2 electrons in the first shell. So we can also write it like this. This hydrogen's 1 electron is shared with this hydrogen's 1 electron. So in between two atoms, when there is 1:1 sharing of electron, what does it mean 1:1 sharing of electron? Each is sharing 1 electron. All right. The bond is a single covalent bond. So what is a single covalent bond? In between the atoms, 1:1 sharing of electrons. 1:1 sharing of electrons. Got it, Hiba? So
Yeah.
in this way, this is a H2 molecule. Copy it, then I will explain you what type of electrostatic force of attraction is this, what is positive and what is negative.
Okay.
Finish, Hiba, shall I rub the board?
Just a second.
Acha.
Okay, done.
Okay. एक minute, my writing device is not responding all of a sudden. Just wait a minute. Okay. So what type of electrostatic force of attraction? What is positive? Inside the nucleus, the protons are positively charged particles, whereas these electrons are the negatively charged particle. Now, we know that negative and negative repel each other. All right, so how come these two electrons are staying together? Why are not they repelling each other? Yes, they have a tendency to repel each other because negative and negative repel each other, positive and positive like charges repel each other. So why are not these negatively charged electrons repelling each other? The reason is that the nucleus have got protons. The protons are the positively charged particles. These protons are actually attracting the electrons like this. So this proton is at holding this electron, this proton is holding this electron. So they are compelled to stay together. If we remove the nuclei or if we remove the protons, then these two atoms will just, bounce back. Did you understand? So what type of
Yeah.
electrostatic force of attraction it is? It is in between the shared pairs of electrons, which are negatively charged particles, and the nuclei of each atom. The nuclei of each atom holding the two electrons together. Otherwise, they would have repelled each other. So this is the example of H2 molecule. Now we will see two chlorine atoms react with each other. Both of them are non-metals to form chlorine. So chlorine's atomic number is 17. 2, 8, 7. So this chlorine has 7 electrons in the last shell. And when we are talking about the same type of the non-metals, we will represent both of them with either these circles or cross. So this chlorine, I have drawn 8 electrons. There must be 7 electrons in the last shell. So there are 7 electrons in the outermost shell of chlorine. All right, so this is another chlorine. This chlorine also has 7 electrons. 1, 2, 3, 4, 5, 6, 7. So this chlorine needs 1 electron. This chlorine needs 1 electron. So when the two atoms in between them need 1 electron, each one of them need 1 electron. So you know what we do? We just simply draw the two overlapping shells like this. This chlorine needs 1 electron. This chlorine needs 1 electron. Remaining how many? 6. 1, 2, 3, 4, 5, 6. This side also. 1, 2, 3, 4, 5, 6. So each one of them need 1 electron. So there will be 1:1 sharing of electron. So in between two chlorine, you can see each chlorine is completing 8 electrons in the last shell. So the bond is again a single covalent bond. So we can write this chlorine's 1 electron is shared with this chlorine's 1 electron. Why 1 electron is being shared? Because each need 1 electron. So when 1:1 sharing of electron is taking place, you will see in the overlapping part, there will be 2 electrons. Overlapping part 2 electron means the bond is a single covalent bond, which is represented by a single line like this. Single covalent bond is represented by a single line like this. Did you understand, Heba?
Yes.
Okay. Shall I rub the board?
No, this is okay.
All right. So see another one, fluorine. Group 7 elements, all of them have got the same bonding. Fluorine. Okay. So atomic number is 9. So 2, 7. So same thing will happen. Each one of them need 1 electron. So this fluorine's 1 electron will be shared with this fluorine's 1 electron, the remaining 6 electrons like this. So again, the bond is a single covalent bond in between two fluorine atoms. So it's an F2 molecule. F2 molecule. Now you will notice one thing. Since sharing of electron is taking place, so no charge is appearing over them. So remember, all the covalent molecules, all the covalent compounds are the neutral molecules. They do not have any charge over them. Why they do not have any charge over them? Because sharing of electron is taking place. The electrons are not going or coming, just they're sharing the electron.
Okay. Mm.
All right, now let's move to another one in which the bond is not a single covalent bond, rather the bond is a double covalent bond. When two oxygen atoms combine together, they form an O2 molecule. Each oxygen has 8 electrons in the atom. That is 2, 6, 2, 6. So each oxygen atom has 6 electrons in the last shell and there should be 8 electrons in the last shell. So what do they do? This one need 2 electrons, this one need 2 electrons. So there will be 2:2 sharing of electron. Why 2:2 sharing of electron? Because each atom need 2 electrons. So this oxygen's 2 electrons are shared with this oxygen's 2 electrons. So out of 6, if I have drawn 2, how many more left? 4. 1, 2, 3, 4. 1, 2, 3, 4. So now let's count this oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. Complete. 1, 2, 3, 4, 5, 6, 7, 8. Complete. In the overlapping part, there are 4 electrons. So the bond is a double covalent bond. Double covalent bond is represented by a double line. So why there is a double covalent bond in between two oxygen atoms? Because each oxygen atom needed 2 electrons to complete the last shell. So there is a 2:2 sharing of electrons. So when there is a 2:2 sharing of electrons in the overlapping parts, how many electrons we are going to see? 4 electrons. In the overlapping part, we are going to see 4 electrons. So double covalent bond is stronger and difficult to break than the single covalent bond. More energy is needed to break this bond. So how we are going to make it? Like this. This oxygen's 2 electron shared with this oxygen's 2 electrons. Remaining 4. 1, 2, 3, 4. 1, 2, 3, 4. Got it, Hiba? Are you
Yeah.
understanding?
Yes, it's pretty simple. Okay, John. John, no.
Okay. Okay. Now see another one. Nitrogen molecule. Okay, when two nitrogen atoms react with each other, they form N2 molecule. So this nitrogen 7 atomic number, so 2, 5. This nitrogen 7 atomic number 2, 5. 5 means in the last shell, each need 3 electrons. All right. According to the need, you are going to share the electrons like this. So this nitrogen need 3 more electrons. So 3 electrons of this nitrogen are shared with 3 electrons of this nitrogen. Out of 5, if I have drawn 3, how many more left? 2 more left. So in the overlapping parts, how many electrons we are seeing? 6 electrons. What is this thing? 3:3 sharing of electrons. Why 3:3 sharing of electrons? Because each needed 3 electrons to complete the last shell. So the bond is a triple covalent bond, which is represented by a triple line. And we can draw it like this. This nitrogen need 3 electron. This nitrogen need 3 electron. Remaining 2.
Covalent bond can happen between two different elements, right?
We have not started it yet. First finish it, then I'll explain you. So see this nitrogen, each one of them is completing the 8 electron, and there are total 6 electrons in the overlapping part. So 6 electron in the overlapping part means triple covalent bond.
Then
Okay. So these were the cases when the 2 atoms of belonging to the same non-metals react. Now different non-metals, okay, which you were asking just now. What about if the elements belong to the different non-metals? So now let's start. Hydrogen react with chlorine. Hydrogen chloride will form. So hydrogen has 1 electron, chlorine has 17 electrons, 2, 8, 7. So chlorine needs 1 electron, hydrogen also need 1 electron, because first shell need 1 electron, so there will be 1:1 sharing. So this is chlorine. Chlorine's atom will be bigger. Why? Because it has got 3 shells. And hydrogen atom will be smaller because it has got only 1 shell. So hydrogen has only 1 electron. It needs 1 more electron. So hydrogen's 1 electron. Actually, let me draw it clearly. We will be showing dot and cross this time because these are the 2 different non-metals. So this chlorine and hydrogen. All right. So hydrogen, 1 electron is needed by hydrogen, 1 electron is needed by chlorine. So remaining 6 electrons like this. So if you will see, chlorine is completing 8 electrons in the last shell and hydrogen is completing 2 electrons in its first shell. So 1:1 sharing is happening. So the bond is a single covalent bond. So we can draw it in 2 different ways. So the bond is a single covalent bond represented by a single line. Got it?
yes.